Hello everyone, myself Bindu GS. These are my team members Bhavana, Divya, Sinchana, Manasa. Today we are going to explain about the deep learning problem statement. Develop a small image classification ensemble combining a CNN and SVM hybrid model. Next, coming to contents, introduction, problem statement, dataset pre-processing, combine CNN, SVM, and extracting CNN feature with SVM, performance matrix, result and discussion and challenges. Next, coming to an introduction, the CNN is extract meaningful feature from images. SVM is classifies those images into an correct categories. The introduction highlights image recognition. It explains that CNN are used to extract and deep visual features from images, while SVM provides robust and accurate classification. This integration aim is to achieve better accuracy, efficiency, and generalizing in visual recognition tasks. Develop a hybrid model that leverages CNN features extraction with SVM classification strength. The CNN extract meaningful image features which are then passes to an SVM to perform the final classification. This approach enhances performances by combining a deep learning representation power with SVS precision in decision boundaries. Sample images of different plant species are shown to illustrate the dataset used for model training and testing. Next, we'll continue by Sinchana.
Coming to the dataset acquisition and pre-processing, which is preparing our visual data, we utilize a standard benchmark image classification dataset. For example, we have CIFAR10 or a custom domain-specific set to ensure a relevance and compatibility. Volume is kept moderate to test the SVM's generalization capabilities. So here we have 3 points where we include image normalization, resizing and cropping, and data augmentations. So image normalization is about standardizing the pixel values. For example, we have 0 to 10 for stable, which is for stable training, and resizing and cropping. Uniform image dimensions. Example, we have that 224 into 224 to match the CNN input requirements. And data augmentations, we have applying rotations, flips, and shifts to improve model robustness and prevent overfitting in the CNN component. Convolutional neural networks, that is CNN, feature extraction powerhouse. The CNN is employed not for classification but purely as a sophisticated feature extractor. The final dense layers, that is before the softmax or sigmoid, are removed, and the output from the layer serves as the input to the SVM. First one, we have input layer, which image data feeds into the network, and CNN core, the central element for automatic representation learning. Third one, we have feature vector output, the high dimensional feature representation passed to the SVM, and convolutional layers learn hierarchical features, which is edges, textures, and object parts. Next one is pooling layers, reduces dimensionality, preserving essentials informations, and flattening FC layers, converts 3D feature maps into a ID feature vector.
Now coming to the support vector machines, the power of the decision boundaries, the support vector components that excels at finding the optimal hyperplane that maximizes the margin between a classes in a high dimensional feature, that is space provided by the CNN. Now the first key point is the optimal separations that maximizes the distance between the hyperplane and the nearest data points, that is enhancing the generalization. It keeps the classes far apart as possible as the better accuracy. Next, coming to the kernel trick, non-linear map features into an higher dimensions using a RBF kernel where and classifications becomes a linear separable. Now coming to the efficiency, the support vector machine training time is the fast, and especially compared to the fine tuning, the classification is ahead of the full CNN, allowing for a quicker and iterations and a robust results. The efficiency which improves the accuracy and the faster and better results. Now coming to the building hybrid, that is integrated CNN features with an SVM. That is the first step. We include a train and a pre-train CNN. Train the CNN using the full data set until the satisfactory representation is achieved. Typically transfer a learning from established architectures, that is a VGGRES net is used. which is used for the training of the model with a data set. Now coming to the feature extractions, that is remove the final classification layer and layer of the trained CNN, that is pass all the training and testing images through a truncated CNN to generate a feature vectors for an each image, that is extracting the features and the layers. Now coming to the training of an SVM, use these extracted features vector as an input and original image labels to train the SVM classifier, and these are the core classification where the classification occurs. Next further will be continued by Bhavna.
Performance matrix. How do we measure the sources? Evolutions are required a comprehensive look behind simple accuracy, focusing on generalizations and reliabilities. 98% classification occurs. The ratio of currently classified image and total number of image in the test sets, and 0.95 is a F1 score, and the weighted average of the precisions and recall for balancing the evolutions across the classes, and 0.99 is a ROC and AUC scores measure the separabilities of the classes and excellent model of performance. And we also analyze the confused matrix to identify the specific classes where the model struggles, false positive or negative. Results and discussions. The y-axis represents as accuracy percentage, and from the 0 to 120. The x-axis compares the three models, standalone CNN softmax and CNN SVM hybrid and Ensemble's voting models. The challenges: why go hybrid? In CNN limitations over RM restrictions, the deep CNS, as especially at the finer classification layer, often suffer from the larger number of trainable and parameter, leading to higher complexity and something's overfitting, and particular with the smaller data sets. And SVM strength is robust classifications. SVMs are highly effective for the classification in the high dimensional space. By using the kernel tricks, they can find optimal separating hyperplanes and hyperplanes with excellent generalizations when the limitation training data. Thank you.
Now coming to the code, here comes an importing of the numpy and the tensor flow, and the importing of the layers and the input layer, and which is the importing of the necessary libraries. And from the sklearn we get a data set, and from a sklearn matrices we get an accuracy score and a classification report and a confusion matrix. So now coming to the data sets, that is we have loading a CFR10 data set, and from the pre-processing data we are standardizing the factors. Now coming to the model selections, that is of the selecting of the CNN hybrid model plus an SVM, that is a train test split. Now coming to the random seed, that is the giving of the random number 42, and here comes to the training of the loading of the data into the training data, that is 80% training data and 20% testing data. Now coming to the input layer, that is an activation function, that is the RELU, and then maximum pooling layer, and the flatten layer, and dense layer, that is an printing of the softmax function, and an output and an input layer. Now coming to the CNN model, that is a compile optimizer is equals to Adam model, and the categorical cross entropy, and the matrices, that is an accuracy. Now it prints the training CNN feature for an feature extractions. Now coming to the CNN model fit, that is extrain epochs, and that is a printing of the epochs, and then validation split, that is equals to 0.2, and the feature extractor, that is an importing of the CNN model input and then output to get an CNN layer, and next coming to the extrain features, that is a training of the model and the test features on an unseen data, and x underscore train features to standardize the training features and to transform into the testing features. Now it prints the CNN training of the SVM on the CNN features. Now coming to the SVM kernel, that is a probability is equal to true, and the random state, that is equal to 5. Now coming to the SVM fit, that is the X-train features and the Y-train features. The CNN props, that is CNN model which predicts on the training data, and the classes, that is on the CNN props of the shapes. So now coming to the for loop, the SVM for loop, that is greater than the probability, and the alpha, that is a learning rate, that is equals to a 0.5, and now it combines with an CNN props and the SVM props to predict the value, and then predict the value. Now coming to the printing of the model performance comparison of the both CNN and SVM, and printing of the CNN accuracy and the SVM accuracy, and then ensemble accuracy, and printing of the classification report and an confusion matrix. Here, coming to the output of the code, we are loading a CFR10 dataset with a training samples of an 10 with a 1 lakh training samples, and the test samples with a 2000. And here coming to training of the CNN feature extraction with the 5 epochs with an respective accuracy and the value that is get lost. Now coming to the model performance comparison, the CNN accuracy is 0.5175 and the SVM accuracy is 0.5390 and ensemble accuracy is 5385. These are the model comparison that we have implemented, that is CNN and the SVM, and total, that is ensemble accuracy. Now coming to the classification report, it performs with a precision, recall, F1 score and the support. So the accuracy of the precision is 0.5378 and recall is 0.5385 and F1 score is 5363 and support is 2000. Now here it prints the confusion matrix of the both CNN and the SVM model, that is a hybrid model. Here is a small project that is guided by our Chaitra ma'am. Thank you one and all.